Alright, continuing on with acid-base concepts. It's very short video, this one, because I just want to mention something about water. Alright, so water is called a substance called amphoteric or amphiprotic substance. Now what it means is that, well, amphiprotic to start with. Amphi means, well, both, or more than one, two. And protic, well, as the name suggests, it's about proton. Okay? Substances that can donate or accept proton is called amphiprotic. Whereas amphoteric means something that can act as base or acid. Acid as a base. Yeah, it's an act as amphoteric. They really talk about similar thing, but amphiprotic focuses about proton, and amphoteric is about the behavior of it. So water, for example, it acts as base if it was reacting with stronger acid than its own, or if it's exposed to stronger base, then it will act as acid. Vice versa. So, for example, water, it's in green color, H2O. If it loses, if it loses electron, loses proton, because it's amphiprotic. If it loses proton, water will become OH minus, or if it gains proton, then it will become H3O plus, hydronium ion. Another substance that can do is do the similar thing is, come on, hydrogen carbonate ion. So hydrogen carbonate ion, when it loses hydrogen, it will be just carbonate ion. And when hydrogen carbonate ion gains hydrogen proton, it will become a carbonic acid, H2CO3, that's carbonic acid. Hydrogen sulfate ion is pretty much the same. When it loses proton, it will become sulfate ion, something that hopefully everyone's familiar with. And hydrogen sulfate against proton, it would be H2SO4, sulfuric acid. So they are examples of amphoteric or amphiprotic substances. You can also say the same thing for hydrogen phosphate ion. Phosphoric acid, for example, H3PO4 can lose and gain 3 protons. It's a triprotic acid, so it can have the intermediate state, and when it's in the intermediate state, they are considered to be amphiprotic or amphoteric substance. That's it.